Hello everyone, good morning to all of you. Myself Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today in this lecture, I am going to discuss about solutions of question bank from Module 4. In this lecture, I want to discuss in detail about Part B, long answer type questions. So how can we solve the long answer type questions from Module 4 in Part B? So in this topic, I am going to discuss about vector differentiation. And in vector differentiation, I want to solve the solutions of question bank from Module 4 in Part B, the long answer type questions. First of all, I want to suggest two references of textbooks for engineering mathematics for second semester. So, which are given as follows. First reference of textbook, the name of the authors are N.P. Wali and Dr. Manish Goyal. Publications Lakshmi Publication Private Limited. And second one reference of textbook is the name of the authors are H.K. Das and Dr. Rama Verma. Publications S. Chand and Company Private Limited. So you can follow these following books. Now I want to discuss about question 1, which is taken from vector calculus and vector differentiation. This is the question taken from Part B, long answer type questions. So question 1 is, so that vector A, here vector A is given in this question. Vector A, this is three-dimensional vector point function. Vector A is three-dimensional vector point function in three-dimensional geometry. Vector A is the position vector of a point from origin. Position vector of a point from origin. So we can discuss this one. This is x-axis, this is y-axis, and this is z-axis. Solution. Start here solution. Given us that vector A equal to 3y to the power 4 z square I cap plus 4x cube z square j cap and minus 3x square y square and k cap. Okay, vector A is a vector point function. Vector point function. Okay, this is the position of a point from origin. Position, vector point function means position of a point in coordinate geometry, three-dimensional coordinate geometry, whose distance from origin in vector form. So I am discussing here, this is point P and coordinates of this point is this one, 3y square, y4 and z square, comma 4x cube z square, comma, minus 3 x square y square. Okay, and this is origin O and OP. This is vector A, OP. This is position vector of P point. P is this point is three-dimensional geometry. So OP is A vector. A vector is given. So now, first of all, so that A is solenoidal. Here we have to prove that vector A is a solenoidal. Okay. Here we have to prove that vector A is solenoidal. So first of all, number one, define solenoidal. Definition of solenoidal. A vector is a solenoidal of a vector. Definition of a vector is a solenoidal. This is definition. Okay. A vector A is said to be solenoidal if divergence of vector A equal to 0. This is the condition. Condition of solenoidal is divergence A equal to 0. This is the condition of solenoidal. If divergence of vector A is 0, then vector A or A vector is said to be solenoidal. Okay. So now, proof. Divergence of vector A this equal to divergence of vector A. Vector A is 3 by 4 z square I, 3 by 4 and z square I cap plus 4x cube z square plus 4x cube z square j and minus 3x square y square k. Okay. So this equal to divergence means del dot. Divergence means del dot of this vector 3 by 4 z square I cap and plus 4 x cube z square j cap and minus 3 x square y square k cap. Okay. So value of del is I dou over dou x plus j dou over dou y and plus k dou over dou z. This is the del. Okay, dot. Here is function this 3y4z square I cap and plus 4x cube z square j cap and plus minus 3x square and y square k cap. Okay, this result where del equal to I dou over dou x plus j dou over dou y and plus k dou over dou z. This is the value of del. So I am putting here value of del this, and this is vector A. So del dot A. Del dot A is divergence. Del dot A is divergence. Here is proof. Divergence vector A. This equal to del dot vector A. Okay, del dot A vector. So here divergence this equal to del dot, this is vector A. Okay, del dot vector A this. So value of del is this and this result. Now here this del is three-dimensional vector operator and A is three-dimensional vector point function. So now taking dot product between del and vector A. So here we know that here I dot I is 1, j dot j is 1, k dot k is 1, I dot j is 0 and j dot k is 0, k dot I is 0. Okay, these are the formulae. So now here differentiating here dou over dou x of here I to I, product between I to I is 1, d over dx, differentiating with respect to x to this function, coefficient of I taking 3 by 4 z square. So here 3 by 4 and z square plus dou over dou by and differentiating here with respect to this is the coefficient 3x cube z square, 4x cube z square, 4x cube z square and plus dou over dou z differentiating minus 3x square and y square. Okay, so now this equal to, so differentiating with respect to x, this result is 0. There is no x, only y and z. Y and z are constant with respect to x. So here differentiating, so this is constant function. This is constant function taking out 3y4z square. Here differentiating 1, no x, and plus here differentiating y with respect to y. So this is constant here 4x cube and z square differentiating with respect to y. So here is 1 and plus differentiating with respect to z. So minus 3x square y square differentiating with respect to z here 1. Okay. So here 3 by 4 z square, this is 0, plus 4x cube z square, this is 0, minus 3x square y square, and this result is 0. Differentiation of 1 is 0. This result is constant. So constant function taking outside. Here is no x. In this function is no x. In this function is no y. In this function is no z. So this function is constant taking out, and there is one function only. So differentiating of y with respect to 1, differentiating 1 with respect to x, differentiating 1 with respect to z. So here we get here divergence vector A, this equal to here 0, 0, here plus 0, plus 0. So this result is divergence A is equal to 0. So divergence of vector point function is 0. So here we see that divergence of a vector point function A is 0, 0. So we can say that vector A is solenoidal. Okay, this is proved. This is proved. Vector A is vector point function, and vector point function is solenoidal if its divergence is 0. Now next, question second. Question second is prove that this is vector point function f. F is this function y square minus z square plus 3yz minus 2xi and minus 3xz plus 2xyj and plus 3xy minus 2xz plus 2zk, both solenoidal and irrotational. Here two questions are there. Number one, we have to prove here that vector point function f is a solenoidal. Okay. Number two, we have to prove that vector f is irrotational. Okay. So first of all, proof 1. Vector f is a solenoidal. We have discussed in just problem 1, vector A is solenoidal. So here solenoidal. So here divergence of f vector, this must be 0. This is the condition. This is the condition of f vector is a solenoidal. Okay. So now divergence f this equal to del dot f. This equal to del I dou over dou x plus j dou over dou y plus k dou over dou z and into f. This is the value of f. F is here. What is f? Y square minus z square. Here is f vector. Okay. So now writing here, this is I dou over dou x and plus j dou over dou y plus k dou over dou z, and here dot. Here x square minus z is y square minus z square and plus 3yz minus 2x into y and plus, here is minus 3xz plus 2xy minus 3xz plus 2xy, and this is j plus, now here 3xy minus 2xz, 3xy minus 2xz and plus 2z into k, okay, into k. So this is dot product must be 0. So product between I to I, j to j, k to k. So here we have dou, this is divergence f, this equal to dou over dou x of, here y square minus z square plus 3yz, y square minus z square plus 3yz and minus 2x plus dou over dou y, here is minus, this term is minus, so I am writing this minus in bracket 3xz plus 2xy and plus k, k is not there, dou over dou x, dou over dou z of, here is 3xy minus 2xz, 3xy minus 2xz and plus 2z, okay. So now here differentiating with respect to x, y is constant, z is constant, yz is constant, only 2x. So here differentiating with respect to x now, differentiating with respect to x, y square minus differentiating with respect to x, z square and plus differentiating x 3yz and minus differentiating x minus 2x only, okay. So now plus minus differentiating with respect to y 3xz and minus differentiating with respect to y 2xy and plus differentiating with respect to z 3xz and minus differentiating with respect to z 2xz and plus differentiating with respect to z of 2z, okay, 2z. So finally we get this result, first is 0, next is 0, third is 0 and minus 2 plus 3xz. So this 0 and next here y. So putting here with respect to y minus 2x and plus 0 and next plus 0, not this. Here with respect to z. So 3x plus 3x with respect to z minus 2x and with respect to x plus 2 only. With respect to z plus 2 only. So this 2 cancel to this do x to cancel this. Not 2x here. 3xz, 3z and 2xz here 2z and 2xy is 2y and here is minus 2 here. So here is 4xz. It is minus 2xz, 2x. Differential with respect to 2x, so minus 2. Differential 3xz. So here is with respect to z is 0. This result is 0. Differential with respect to z minus 2x. Differential with respect to z 3x. differential with respect to x. Here is only xz. In starting, function is wrong. Okay, no problem. So here is, we get this result is minus x. So we can write here divergence of f is not 0. So we can say that f vector is f vector is not solenoidal. Okay, this is proof. Now proof second. Proof second. F vector is a irrotational. Okay. So first of all, we define irrotational. Definition irrotational function. Function is irrotational. Function f, vector point function f is irrotational. Okay, irrotational. So if a function f is verify the condition del cross f, or we can say curl f, or this equal to del cross f. This must be 0. This is the condition of irrotational. Okay, curl f equal to del cross f equal to 0. Then vector f is irrotational. Okay, vector f is irrotational. So now proof. Del curl f, this equal to del cross f. This must be 0. So taking LHS, curl f, this equal to del cross f, this equal to vector. Determinate. I am writing determinate. I, j and k. Dou over dou x, dou over dou y, dou over dou z. Now y square minus z square, y square minus z square, y square minus z square, and function is 3yz plus 3yz and minus 2x. Next y, 3xz plus 2xy minus 3xz minus 2xy, and next 3xy minus 2xz, 3xy minus 2xz, 3xy minus 2xz and plus 2z. This is determinate. So now solving this, here I this equal to curl f del cross f. So now this equal to I cap here. So here differentiating this, I first column and first row. First row, first column cancel. Differentiating with respect to y. So dou over dou y of here do over 3xy minus 2xz, 3xy minus 2xz, and here plus 2z minus dou over dou z, and differentiating this with respect to minus 3xz minus 2xy, minus 3xz minus 2xy, 3xz minus 2xy. Okay. Next result here plus dou over dou y. Second is minus. This is I cap minus j cap, and here j cap. Second column and first row cancel. Second column, first row cancel. Dou over dou x. Dou over dou x of this result 3yz minus 3xy minus 2xz. 3xy minus 2xz and plus 2z minus dou over dou z. Here dou over dou z of y square minus z square, and here is y is plus 3yz and minus 2x this result, and plus k cap here. So in k cap, third column and first row cancel. So dou over dou x of 3xz minus 2xy minus 3xz minus 2xy, and dou over dou y of here dou over dou y of y square minus z square plus y square minus z square plus 3yz and minus 2x. Okay. Now differentiating each term properly. So I cap here, differentiating this y with respect to y here. So here is only 3x, and differentiating with respect to z. Z is here 3xy. So here is z is 3x 2xy. So with respect to z minus 3x minus here minus 3x. So minus plus 3x. Okay. Next minus j. Minus j is differentiating with respect to x. X means here minus 3y here and x minus 2z. Next differentiating with respect to z this. So minus here minus plus 2z and plus 3y. Okay. And now here differentiating with respect to plus j and plus k here. K. So k differentiating with respect to x here and minus 3z. X here minus, this is 2xy minus 2y, and minus here y 2y minus plus 2y, and here plus 3z. Plus 3z means minus 3z minus 3z. So here is minus 3z with respect to y1 minus 3z. Okay. Now first checking the question, starting 1 plus 3yz minus 2x. Okay. So this is here. Next, this equal to I. Here is 6x and minus j. Here is 2z cancel. Here is 6y and plus k. Here 2y cancel, minus 6z. So now curl f, this equal to del cross f, and this equal to value. Here is I 6xi and minus 6yj and minus 6zk. Okay, we see that curl f equal to del cross f is not 0. So the vector point function f is not irrotational function, irrotational vector point function. Okay, function. This is proved. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.